Hi Rahul.
Hi, sir.
So you are presenting the solution demo for fintech risk scoring engine using agentic AI, right?
Correct, correct. Yes, sir.
So in this project, you are using ETL process with ADF, Azure Data Factory, and dashboards. And within transformation of the ETL, you are using the agentic AI
Ye-
workflows, and also you are using LangGraph, LangChain,
Yes,
and Databricks, and you are using Power BI for dashboards, right?
dashboard, yes.
Finally.
Yes,
Okay.
yes.
Yeah, yeah. Please go ahead.
Okay. Hello, everyone. My name is Rahul Patel from Mumbai, and uh, this is my LinkedIn ID. And today's my demo is regarding to the solution demo on the fintech risk scoring engine using agentic AI. This demo is done through the job question. My coach name is Shanti Kumar V, and here is LinkedIn ID. So today's initiative in the today's era in the fintech industry uh, to detect the fraud and access credit risks real time by using cutting edge AI technology, scalable infrastructure. It is very important to in the financial domain. And so today I will walk through the all the what will be I will do in this the solution demo from business requirement, user story, demo objective, and sprint by sprint plan to deliver the solution. So I will walk through the whole presentation. So the demo objective is to uh, fintech risk scoring engine. This is AI power fraud detection projects in a real time scenario. So first business requirement. So the financial institute lack of scalable real time and explainable fraud credit risks accessible pipeline. So so in the our financial institute face a critical challenges detecting the fraud, accessing the credit risks in a real time, while ensuring scalability and compliance. The business requirements are very clear. We need a system that detect the both traditional and synthetic fraud instantly. So score creditworthiness using the diverse data source and provides explainable AI narrative for transparency. So by the using the this using this is a real time business requirement for the in our financial institution. So in this we are going to use the we are using real time detect the real time fraud and create worthiness. So trash the audit all the model prediction, and with the help of Gen AI and the agentic AI, we are detect the we are going to be detect the frauds. So handle the this is to meet the this need. This is a real time requirement of the of the business. So this is a uh, graphical representation of implementation scalable risk assessment pipeline. We had limited scalability real-time capabilities and build a scalable real-time and explainable risk assessment pipeline. And output is a scalable real-time fraud and credit risk assessment. This is our business requirement. Now, moving next to the slide is regarding the user story. User story is the stakeholder demand efficient, automate process, actionable insight for risk management. From data science to operations, streamlining tool and transparent monitoring are essential for reliability. And this is a graphical representation of the user story. To ensure that our solution meet diverse need, we have crafted our user story in the key role. Like data scientists want to automate the feature engineering to save time, manual tasks as a fraud analysis. In I need a real-time alert with a clear explanation to act. So here, ML engineer want to drift monitoring also, and DevOps engineer uh, teams need to uh, DevOps engine team need to matrix to ensure system healthy. They are keep watch on the models. So all these are the user stories, and this is a graphical representation. Here automate process, and here is a transferring, monitoring, and risk management. Next one is a uh, demo objective. So demo objective is to uh, wait, demo objective to this is a demo objective. Demo objective, our demo will be bring this vision to life by showcasing the full pipeline, data injection to feature engineering, prediction. Then we will demonstrate multi-model interface for fraud and credit scoring powered by LangGraph agent. Using fast API interface, we will input sample customer data, retrieve risk score, then GenAI explanation and tracks ID in real time. We also highlight drift detection and retraining logic with the visualization of the traces store in Azure Blob. We store all these traces in Azure Blob, and this demo will prove the system end-to-end functionality. So this will be the our demo objective from injection, feature engineering, prediction, traceability, and drift detection. This is the graphical representation of demo objective pipeline. And here we are going to use the technology Azure Blob, LangGraph for the drift detection, LangChain, and the ETL pipeline, fast API interface. So these are the demo objective, and these are the technology we are going to use. Next is data preparation. So focusing on the laying the groundwork with the data preparation, our goal is to create clean and synthetic customer data and the foundational document for the RAG, retrieval argument creation. We will clean data set. We have clean data set, suppose customer.csv. It is our clean data set, and generate the synthetic fraud cases using SDB. Yes, why use SDB? SDB for the mimic the real-time data. That's why we use SDB. And we will also convert policy rules and fraud case document into the vector database. Here we can see we can create, and then this data we are going to upload into Azure Blob. And by the end, we have to clean data set and data dictionary, and a knowledge base is ready for the downstreaming task. So in this sprint, we prepare the data. This our main goal is to prepare data, prepare synthetic custom data, and foundational document for RAG integration. And here is all the step by step. Here we are mentioned here: clean data, generate fraud data, anonymize PI, create policy rule, and convert to vector database. And this all the data we have to upload into the Azure Blob. So here this is a slide regarding to data preparation. Then moving to next step, real-time batch injection. So after completion of sprint 1, so now we are landing to set up the real-time batch injection of low latency scoring. For low latency scaling, we will design a Azure Data Factory pipeline to handle both batches and streaming data via Azure Event Hub. Raw data will be stored in the Azure Blob, and the Databricks notebook will be trigger processing. So here, after storing the data into the Azure Blob, the database notebook will be stored, and after the notebook will be triggered, then data will be pre-processed, ensure data flows seamlessly into our system. And by the end, we have robust injection pipeline and ready to support our ML workflow. So these are the batch injection and the real-time batch processing, data processing. this this task we are performed in this slide, real-time batch injection. So this is a graphical representation. So real-time injection and batch injection is a design, configure Azure event for, and here a design ADF update using ADF. Here also update using Visual Store in a block. Then trigger database notebook for the processing, and deliver event hub config, ADF pipeline or Azure block, and security key vault, and here also security. So this is the real-time batch injection process in this sprint. Next is the ETL and the feature engineering. We focus on the ETL and automate the feature engineering using Databricks. We will load the data and apply tools to create the high quality features for ML or an agentic workflow. So here we use Databricks for the load data and create the high quality features for ML and agentic workflow. We also generate embedding. Here we can say we also create the embedding from unstructured text data and store in a vector store. So the vector store will be Fuzzy or ChromeDB, and the Fuzzy or ChromeDB vector store for embedding and reusable feature engineering notebook. And we can use this vector DB database for the querying purpose also. With the help of our key API key, we can perform querying on that particular database and get the information in real time from that particular data. So this is the ETL and feature engineering process. So here is the flow for the load the data, feature engineering, save process data, generate embedding, save that embedding also in vector store, and lastly deliverable. So this slide show the ETL and feature engineering process. So next slide is regarding the training and drift monitoring. So in this slide, we are focusing on the training the model and monitoring their performance. We split the data into split data, and then we are going to use XGBoost or the light JBM classifier. And after training the model, we will evaluate their accuracy using F1 and AUC matrix. And shape feature explainable also. The model will be registered in Azure ML with drift monitoring via evidently AI to trigger retraining when needed. By the end, we have the production ready model and the uh, drift report also. So in this slide, we are going to train the model training, then model evaluation, then feature explanation, model registry, and drift monitoring. So this is the process of the model training and drift monitoring. Now here come the agentic part. Next slide. So now we are the stage where build a intelligent agent pipeline using LangGraph and LangChain. We integrate Azure OpenAI GPT 3.5 Turbo model for natural language processing, indexing our knowledge base in the on the this Fuzzy or ChromeDB vector database for the RAG. LangChain tool will be enhance the agent capability, and we will also use Langsmith for the debugging or observability. So Langsmith tool we are going to use for the debugging and observability. And in this whole process, deliverable will be include workflow code, tool, vector database, and Langsmith dashboard to monitor the performance. So with the help in this, after this completion of agent will be ready, and then we move to the next part. So in this process, agent will be ready. So in the help of LangGraph, we will create the nodes, edges, create the functions, and create the tool. With the help of that function, we call that particular agent we are built for the perform the particular task. So here is the flow. This debugging, knowledge indexing, Azure OpenAI, LangChain tool, and agentic workflow. So this first here agentic workflow. then LangChain tool, then we Azure OpenAI tool, knowledge indexing, and then debugging. So this will be the workflow for the agentic AI development. Now, next slide is API integration. So, s- so REST API using fast API, the elevate risk endpoint will be accept customer profile and return risk score. Generative AI explains and trace the ID. We will containerize the app with help of Docker and deploy to the Azure Container app using the Kubernetes and implement. By the end of this, we will have to live endpoint and UI document ready for the testing. So this is the front end API testing. So here we are going to use REST API to serve risk score and explanation, and we're going to use Docker for containerization purpose, and the return will be credit risk fraud score explainable tracks ID. This will be the returnable in this API integration. Now next slide is regarding the MCP. Yeah, here in this, we focus on the traceability and auditability. We will define the model compliance package schema using Pydantic, saving across the Azure block. Each API response will be include and trace ID for auditing. We will also integrate Azure for data lineage, use application insight for the visualization, and in this deliverable include the MCP schema, trace log, and catalog, pure catalog. And after this completion of this, we in this we use Pydantic schema for the uh, it will be help in a production for the give the data type. But it help in a static data pipe, and here we store the logs also. Azure POV for integration, integrate with the Azure POV for linkage tracking, and then visual tracking. So at the end of the days, we got the JSON format output. Now, next is a visualization, GNA summaries and alerts. So we enhance the transparency with visualization alerts. We will also build a Power BI to display the pipeline metrics and risk trend. And GenAI will be generate concise summary for the leadership, and they explain the key decision. We also configure alert for model drift and data anomalies here also, anomalies, and ensuring proactive monitoring. And the deliverable includes interactive dashboard, alert configuration, and sample summary report. It will be created with the help of the Power BI. And this will be the my presentation. After this, we will get lastly the dashboard, GNI summaries, and model drift alert. And with the help of the dashboard, we can make the business decision, and it will be helpful in the make the future decision with the help of this. So sir, this is done with the my demo.
Okay, good. So let me stop recording.